Hi everyone, Jason here at the Whittier Public Library Children's Department with our latest STEAM-powered science take-home science kit activity. Today we're going to be honoring St. Patrick's Day by making our own pot of gold at the end of the candy rainbow. And we're also going to learn a little bit about solutions, dissolving, and a little bit about rainbows. So let's go ahead and get started. Okay, so let's make our rainbow. So the first thing we're going to do, we're going to take our candies and we're going to arrange them around the edge of this plate in the order of the colors of the rainbow. And if you have a hard time remembering, remember the name Roy G. Biv. That's for red, orange, yellow, green, blue, indigo, and violet. We don't have indigo today, but we do have blue. So violet is purple. So let's go ahead and get those arranged. I'm going to go ahead and speed this up so you can see it a little more quickly. Okay, that's just about perfect. Put these aside. And what I'm going to do first is I'm going to grab 2 or 3 yellows and put them right in the middle. That's our pot of gold, which we need at the end of our rainbow, right? Okay, we've got this all set up. Next thing we're going to do, we're going to take our water. Remember, just regular room temperature water from the tap. And we're going to pour it carefully in there, not too slowly, but make sure you pour it carefully so that none of the candies move around. So let's go ahead and start pouring our water. Cover the candies about at least halfway. And then we're just going to stop and wait and watch our rainbow form. You can see the colors start to move toward the center. Now we're going to go ahead and watch this until it reaches all the way to the center. And we see our pot of gold in the center, and our rainbow has now reached the pot of gold in the center of the rainbow. Okay, next we're going to try this with some warmer and some colder water and see if that affects the speed of our rainbow forming at all. Okay, now for part 2 of the experiment. We're going to see if temperature affects how fast the rainbows form. So we have over here some hot water, which I recommend you just use hot water from your tap. Don't use boiling water because you might hurt yourself. So just let your tap run for a while until it gets hot, and then use that hot tap water. Make sure you don't hurt yourself with that. On the other side, we're going to use some cold water. I put some ice in this water for a little while to chill it so it's nice and cold. Now we're going to pour these in. Just go ahead and use whatever orientation you want this time. You can just set them up randomly. I also use the color wheel here, which is something we're not going to talk about today, but is cool to read about. So if you ever get a book at the library, definitely read about the color wheel. So we're going to pour these in. Try and do this at the same time. You're going to have hot on the right. You're going to have cold on the left. You're going to pour those into the center. And you're going to get them filled up, and then we'll see how fast the rainbows form. See which one wins the race. Oh, you can already see the hot one forming pretty quickly. The cold one doesn't seem to be moving much at all. Oh, the hot one is pretty much finished already, and let's watch the cold. Oh, the cold's just starting to come out. Looks like hot definitely won this race. Now let's watch the cold as it finishes. There it goes, still creeping toward the middle. Hot is already starting to mix its colors a little bit, looks like in the middle. While cold is still going. And it looks like cold finally made it to the middle. Okay. So hopefully you found your own pot of gold at the end of the candy rainbow. So let's talk a little bit about what happened here today. When the water is poured onto the candies begin to dissolve. Now, what does that mean? Well, water, the sugar in the candy, and pretty much every other thing is made up of very, very tiny pieces called molecules. And what happens when they dissolve is that the molecules of the sugar mix in with the molecules of the water and create a mixture called a solution. And when that happens, the dye also moves into the water along with the sugar. That's why you get the colors forming the rainbow. Now, how does this happen? What happens is that water and sugar are both made up of very, very tiny little pieces called molecules. And it just so happens that water and sugar molecules are attracted to each other, which means they kind of stick together a little bit. Now, water molecules or any liquid, the molecules are constantly in motion. They're moving around all over the place all the time. And when the water molecules move, they bump into the candy, which is the sugar molecules. When they bump into the candy, they often grab on a little bit and start pulling the sugar molecules off and mixing them in with the water. That makes the solution. And when that happens, the color, the dye, also comes along with them, the molecules of the dye, and that's why you see the colors moving into the water and forming the rainbow. So in part 2 of the experiment, why did the rainbow form faster in hot water than it did with cold water? Well, temperature in a liquid is basically a measure of how fast the molecules are moving. Higher temperature means they're moving faster, lower temperature means they're moving slower. So when you have the hot water, the molecules are moving faster. So because they're moving faster, they're colliding more often with those sugar molecules. Also, because they're moving faster, they're hitting harder, which makes it easier for them to grab on and break those sugar molecules off. That's why the solution forms a lot faster in hot water than it does in cold water. Well, that's it for our experiment today. Thank you for joining us. If you'd like to learn more about any of the topics we discussed today, feel free to stop by the Whittier Public Library and ask our friendly librarians to help you find some books about color, rainbows, chemistry, solutions, or any other topics. We'll see you soon at the library. Goodbye.